Imagine standing outside on a warm afternoon. The sky is blue. The air is calm. Sunlight touches your skin, and everything feels peaceful.
But 93 million miles away, the source of that light is not peaceful at all. It is a roaring nuclear furnace.
A gigantic sphere of plasma, so powerful that every second it releases more energy than humanity has produced in all of history. It throws storms into space. It bends magnetic fields. It blasts charged particles across the solar system.
And one day, it will change Earth forever. This is the Sun, the star that gives us life, controls our planet, and hides forces more terrifying than most people realize.
Welcome to Infinite Science. Today, we are going inside the Sun. Not just the bright yellow disk we see in the sky, but the real Sun, the violent, unstable, star-powered engine at the center of our solar system.
Because the truth is simple. Without the Sun, Earth would be a frozen dead rock. But with the Sun, Earth is constantly living under the influence of a cosmic giant.
The Sun is so massive that it contains about 99.8% of all the mass in the entire solar system. That means almost everything — Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, moons, asteroids, comets, and dust — makes up only a tiny fraction compared to the Sun.
Its gravity holds the solar system together. Earth does not simply float through space freely. It is trapped in the Sun's gravitational grip, moving around it at incredible speed. Every year, our planet completes one orbit around the Sun.
Every day, sunlight powers weather, warms oceans, grows plants, and drives the cycles of life. But the Sun is not just a ball of fire. In fact, fire is not even what powers it. Fire needs oxygen. The Sun does not burn like wood or coal.
The Sun shines because of nuclear fusion. Deep in its core, temperatures reach around 15 million degrees Celsius. The pressure is almost unimaginable. Hydrogen atoms are crushed together so violently that they fuse into helium. During this process, a tiny amount of mass is converted into energy.
That energy becomes light, heat, radiation, and the sunlight that eventually reaches Earth. But here is the strange part. The sunlight hitting your face today did not begin its journey today.
Energy created in the Sun's core can take thousands of years to escape. Photons bounce around inside the Sun, colliding again and again through dense layers of plasma. They move in a chaotic path, trapped inside the star for an incredibly long time.
Then, once that energy finally reaches the surface, it travels through space at the speed of light. About 8 minutes later, it reaches Earth. So when you feel sunlight, you are feeling energy born deep inside a star, long before it ever touched our world.
The Sun is divided into layers. At the center is the core, where fusion happens. Above that is the radiative zone, where energy slowly moves outward as radiation.
Then comes the convective zone, where hot plasma rises, cools, and sinks again, like boiling water. At the visible surface is the photosphere, the layer we see from Earth. Above that is the chromosphere, and beyond it is the corona, the Sun's outer atmosphere.
The corona is one of the Sun's greatest mysteries. You would expect the Sun's surface to be hotter than the atmosphere above it, but the corona is far hotter. The surface is around 5,500 degrees Celsius, while parts of the corona can reach millions of degrees.
Scientists are still studying exactly why this happens. The answer likely involves magnetic fields, waves, and explosive releases of energy. This is where the Sun becomes truly dangerous. Because the Sun is not still. It rotates, it churns, it twists.
But it does not rotate like a solid planet. The Sun is made of plasma,
so different parts rotate at different speeds. The equator rotates faster than the poles. This twists the sun's magnetic field into complex shapes.
Over time, magnetic lines become tangled, stretched, and unstable. When they snap and reconnect, huge amounts of energy are released. This can create solar flares. A solar flare is a sudden explosion of radiation from the sun's surface.
These explosions can release energy equal to billions of nuclear bombs. From Earth, the sun may look calm, but through special telescopes, it is covered in loops, arcs, eruptions, and storms.
Some solar flares are small. Others are powerful enough to disturb Earth's upper atmosphere, interfere with radio signals, and affect satellites. But solar flares are not the only threat. Sometimes the sun launches something even larger, a coronal mass ejection.
This is when the sun throws a massive cloud of charged particles into space. These clouds can contain billions of tons of solar material. They race through the solar system at incredible speeds. Most miss Earth, but when one hits our planet directly, the effects can be serious.
Earth has protection, its magnetic field. This invisible shield surrounds our planet and deflects much of the solar wind. Without it, Earth would be far more exposed to radiation and charged particles.
When solar particles slam into Earth's magnetic field, they can create auroras, the northern and southern lights. These glowing curtains of green, red, and purple light are beautiful, but they are also evidence that the sun is interacting violently with our planet.
A strong solar storm can do more than create lights in the sky. It can disrupt satellites. It can interfere with GPS. It can damage communication systems. It can expose astronauts to dangerous radiation. And in extreme cases, it can affect power grids on Earth.
One of the most famous solar storms happened in 1859. It is known as the Carrington event. A massive solar eruption struck Earth. Auroras were seen far from the polar regions. Telegraph systems sparked, failed, and even shocked operators. Back then, the world was not dependent on satellites, global internet, GPS, or massive electrical grids. Today, a similar event could be far more disruptive. Modern civilization is deeply connected to technology. Satellites help with navigation, weather forecasting, banking, communication, military systems, and emergency response. A major solar storm could damage spacecraft electronics, interrupt radio communication, and create power grid failures. The sun is not trying to harm us. It is simply doing what stars do. But because we live close enough to depend on it, we also live close enough to be affected by its violence. The sun goes through an 11-year solar cycle. During solar maximum, the sun becomes more active. Sunspots increase. Solar flares become more common. Coronal mass ejections are more likely. Sunspots are darker areas on the sun's surface. They look dark because they are cooler than the surrounding surface, but they are still extremely hot. They are caused by intense magnetic activity. The more sunspots we see, the more active the sun usually is. But even during quieter periods, the sun is constantly sending out solar wind. The solar wind is a stream of charged particles flowing outward from the sun. It fills the solar system and shapes the space environment around every planet. Earth moves through this wind constantly. The sun is not just shining on Earth, it is touching Earth with invisible particles every second. And yet, despite all this danger, the sun is also the reason life exists here. Its energy drives photosynthesis. Plants use sunlight to turn carbon dioxide and water into oxygen and sugar. That process supports food chains across the planet. The oxygen we breathe is connected to sunlight. The food we eat is connected to sunlight.
Even fossil fuels are ancient sunlight stored in chemical form from life that existed millions of years ago. The water cycle also depends on the sun. Sunlight warms oceans, causing water to evaporate. That water forms clouds, falls as rain, fills rivers, and supports life on land.
Wind exists largely because the sun heats Earth unevenly. Weather systems, ocean currents, seasons, and climate are all connected to solar energy. The sun is the engine of Earth's environment, but the balance is delicate.
Too little solar energy and Earth freezes. Too much and Earth overheats. This is one reason Earth is special. It orbits in the habitable zone, the region around a star where liquid water can exist on a planet's surface.
Venus is closer to the sun and became a hellish world with extreme heat and a thick carbon dioxide atmosphere. Mars is farther away and is cold, dry, and thin atmosphered. Earth sits in between, not too close, not too far.
But this balance will not last forever. The sun is middle-aged. It formed about 4.6 billion years ago from a collapsing cloud of gas and dust. Gravity pulled material inward. The center became hotter and denser until nuclear fusion began. A star was born.
Since then, the sun has been converting hydrogen into helium in its core, but its fuel is not infinite. Over billions of years, the sun slowly changes. It is gradually becoming brighter.
In the distant future, this increasing brightness will affect Earth. Long before the sun dies, Earth may become too hot for life as we know it. Oceans could evaporate. The atmosphere could change. The planet could become uninhabitable.
Eventually, the sun will enter its red giant phase. As it runs low on hydrogen in the core, its outer layers will expand dramatically. The sun will swell to enormous size. Mercury will likely be swallowed. Venus may also be consumed.
Earth's fate is uncertain, but even if it is not swallowed, its surface will be destroyed. The planet that once depended on the sun for life will be scorched by the same star. After the red giant phase, the sun will shed its outer layers into space.
What remains will be a white dwarf, a small, dense stellar remnant. It will no longer shine like the sun we know today. The solar system will become a colder, darker place. But this is billions of years away. For now, the sun continues to shine.
It remains stable enough to support life, but stable does not mean harmless. Every day, scientists monitor the sun. Space agencies use satellites and solar observatories to watch its surface, measure solar wind, and track eruptions.
This field is called space weather. Just like meteorologists forecast storms on Earth, space weather scientists try to forecast storms from the sun. The goal is to protect satellites, astronauts, power grids, aviation systems, and communications.
The more advanced civilization becomes, the more important solar monitoring becomes. Because the sun is not just an object in the sky, it is a force that can affect the entire technological world, and there is still much we do not understand.
Deep. Why is the corona so hot? How exactly do solar flares accelerate particles so quickly? Can we predict dangerous eruptions far enough in advance? How does solar activity influence Earth's atmosphere over long periods?
Scientists are working to answer these questions using missions that get closer to the sun than ever before. NASA's Parker Solar Probe has flown through the sun's outer atmosphere, becoming the closest human-made object to the sun.
It is studying solar wind, magnetic fields, and the corona in extreme conditions. The spacecraft must survive intense heat and radiation. It uses a special heat shield to protect its instruments while traveling at astonishing speeds. The mission is helping scientists understand how the sun works from close range.
This is one of humanity's boldest scientific achievements. We are not just watching the sun from Earth anymore. We are sending machines into its atmosphere.
The sun has shaped human history in more ways than we often realize. Ancient civilizations worshipped it, farmers depended on it, calendars were built around it, seasons guided survival. The sun told people when to plant, when to harvest, when to travel, and when winter was coming.
Today, we understand the sun scientifically, but that understanding makes it no less amazing. In some ways, it makes it more astonishing. We now know that every sunrise is powered by nuclear fusion. Every shadow exists because Earth is being flooded with photons from a star.
Every warm day is the result of energy crossing space from a sphere so massive that 1,000,000 Earths could fit inside it. And yet, from our perspective, it rises quietly. It sets beautifully. It paints the sky orange and red. It gives us daylight, warmth, and life.
But behind that beauty is violence. The sun is a paradox. It is life-giving and destructive, stable and explosive, familiar and mysterious, beautiful and terrifying. It is the reason Earth is alive, and one day it may be the reason Earth becomes unlivable.
So, the next time you see the sun, remember what you are really looking at. Not just a bright circle in the sky, not just daylight, not just warmth. You are looking at a star, a nuclear engine, a magnetic storm machine.
A cosmic giant holding entire worlds in orbit. And even from 93 million miles away, it controls more of your life than almost anything else in the universe. The sun is not just above us.
It is around us, inside our climate, inside our food, inside our history, and inside the future of our planet. It is the heart of the solar system, and we are living in its light. But we are also living in its shadow.
Because the sun is more terrifying than you think, and we have only just begun to understand it. Thanks for watching Infinite Science. If this journey changed the way you see the sun, make sure to like this video, subscribe, and keep exploring the universe with us.
Because the more we learn about space, the more we realize one thing. The universe is not just beautiful, it is powerful beyond imagination.